Alright, well let's take a look at a few examples of writing polynomials given their roots. And for example, let's say I told you that the roots of a polynomial were 7, 3, and negative 4. And our polynomial was degree 3. So, our polynomial, remember it's always y equals, and then x minus the root is a factor of the polynomial. So this would be x minus 7, x minus 3, and x plus 4. Another one. Let's say we were told that the roots were negative 3, negative 2, 0, and 5, and it was a degree 4. Well, y would equal x minus negative 3, x minus negative 2, x minus 0, and x minus 5. Well, we can simplify this up a little bit. X minus 0 is just x. X minus negative 3 is x plus 3. X minus negative 2 is x plus 2. And x minus 5. Alright. Now, remember we talked about multiplicity, and that's how many times a root would be repeated. So let's say that we had roots 2, but it had a multiplicity of 3 and 5 with a multiplicity of, let's say 4. So x minus the root, x minus 2. Multiplicity is 3. That means that root is repeated 3 times, so actually 2 and 2 and 2 are roots. So instead of writing that out 3 times, we just go cubed. 5 is a root, x minus 5, and it has a multiplicity of 4. 4. And there we go. There's the function. Let's do another one. Let's say we told you that the roots were 0 with a multiplicity of 6, 7 with a multiplicity of 4, and 3. So y would equal, well, x minus 0, multiplicity of 6, so that's raised to the 6th power. X minus 7, multiplicity of 4, so that's raised to the 4th power. And x minus 3. And well, we could rewrite this just as x to the 6th power, x minus 7 to the 4th power, and x minus 3. Okay? Now, let's take a look at an equation. Let's say we had x plus 3 squared, x minus 2 cubed, and x minus 4 squared. Now, remember we talked about even and odd multiplicity. Right? The 2's would be even numbers and the 3's would be odds. And if we thought about the graph of this, well, we know that there's a 0 at negative 3 because it's x minus the root. So there's a 0 at negative 3. There's 1 at 2. And there's 1 at 4. Now, remember that an even multiplicity means that the graph comes up to the x-axis, touches it, and then turns back. And then goes to the next 0, and it's an odd multiplicity, so it crosses the x-axis, makes a turn, comes back. Ooh, we might have to move 4 over just a little bit. There's 4. In the even multiplicity, it touches and turns. It keeps going on. And it would have some sort of general shape like that. Let's take a look at one more. Y equals x plus 5, x plus 2, x minus 1 squared, x minus 3 cubed. So, as we look at this, we know we have a 0 at negative 5. We know we have one at negative 2. We know we have a 0 at 1. And we know we have another one at 3. So, we've got one at negative 5, negative 2, 1, and 3. So, now we always start in the lower left-hand corner because x values are increasing that way, and we always work low to high. So, x plus 5, that's to the first power. Well, that's an odd multiplicity, so it crosses. And then it's got to come up here and turn around. It gets to x equals negative 2. That's x plus 2 to the first power again. That's an odd multiplicity, so it's got to pass through. Turns around, comes back to x equals 1. That's an even multiplicity, so it's got to touch and turn there. And then it comes down, turns back around, and goes to x minus 3, or x equals 3 for the 0. That's to the third power. That's an odd multiplicity. So it continues right on through. Okay. And that's what that looks like. And hopefully that's helpful. If you have any questions, feel free to ask me tomorrow in class or some other time. And have a good night.